Alrighty, so this is section 3.2b, the second half of the slope of 3.2, obviously, slope of a line. Last time, we left off by finishing this problem together, and then I asked you guys to solve this one. Now, hopefully, you found that the slope was equal to -2, but let's do that one together just to remind ourselves. So we have 4x plus 2y is equal to 16. And now we're going to try and get y by itself so we can put it in slope-intercept form, right? So we're going to move that x over. And we end up with 2y is equal to -4x plus 16. Divide by the 2, you get y is equal to -2x plus 8, right? And we got to divide everything across the board by 2, not just the 4, right? Alright, so we can pull the slope out now. Now that it's in slope-intercept form, y equals mx plus b, then that slope is going to be m is equal to the thing next to x or -2, and so our slope was -2. Alrighty. The concept we're going to start off with today is using those ideas to graph the line. So remember, slope-intercept form, is that same form y equals mx plus b. And remember, the name is not trying to trick you, it's trying to tell you what's in that form, right? So if y equals mx plus b is slope-intercept form, well then m is our slope and b is our y-intercept. So that's exactly what it's trying to say, slope-intercept form. Alright, we can use this form to graph very easily. Let's take a look at 3.1a. Graph the line with slope 2/3 and y-intercept of -4. Well, this sounds like the two pieces we need to create a slope-intercept form. So why don't we just go ahead and do that? So our slope and our y-intercept, just remind ourselves that m is our slope. So here, if our slope is specifically 2/3, that means m is 2/3. And if our y-intercept is at -4, then our b is -4. And we have our y-intercept form. Now you might be thinking, how can the y-intercept be -4? That doesn't make much sense, right? Because our y-intercept should be a point on the graph. It shouldn't be a number. It should be an ordered pair. So how can we convert this y-intercept of -4, this b of -4, into something that actually makes sense? Well, let's think about exactly how a y-intercept looks, right? We know that b is equal to -4, but a y-intercept, that is the point on this line where it crosses this y-axis, right? So we've gone over nothing and it crosses the y-axis. Since we've gone over nothing, that means that our coordinate pair must have a 0 of x, or an x of 0, right? And we've been talking about this a few times now. X must be 0. If it's not a y-intercept, right? At some point on the graph. So we know x must be 0. Therefore, if x must be 0 and b is -4, then b must be talking about our y value. B must be our y value. So our -4 is the y value, and our whole point is 0, -4. Awesome. Let's use this point to start graphing. So let's start at 0, -4. Let's use this as a starting point. A start. So let's go to 0, -4, and remember that means over nothing and down 4, that place on the y-axis. So down 1, 2, 3, 4 is right about there. Cool. And that'll be our starting point, because we know it's supposed to cross right there. So let's start with what we know. Now let's take a look at that slope. That slope was m is equal to 2/3. That's 2/3. How exactly could we use the slope 2/3 as to help us graph? How could we do that? Well, remember that slope is the steepness of the line. It's our rise over run. So 2/3 is the same thing as our rise over run. Now, if that's true, then that must mean that the 2 is the rise and the run is 3. So up 2 and over 3. Now here's where we got to be really careful. We don't want to start that from 0. Right? Because we know it doesn't cross at 0, 0. We know it doesn't go through 0, 0. It goes through a different point. So we want to use our starting point, our y-intercept. We want to start from our y-intercept, and from there, let's rise 2 and run 3. So we'll go up 2 and out 3 to get our second point right here at out at 3, -2, right? And then any 2 points make a line, so we can just, oops, my apologies, we can connect those two to create a line. And once again, I'm okay with your lines not being perfectly straight, right? Because the algebra is really what the numbers we're after anyways, and just like myself, we're not the best artists in the world. If you manage to pull out a straight line, go for it. But I'm not expecting you to break out rulers or anything. You're welcome to, as long as it goes through both points and you've got the algebra over here to justify it, it doesn't have to be super straight. But that's the line we get. That's our line of the equation y equals 2/3 x minus 4 in slope-intercept form. All right. So that's how we would use the y-intercept and the slope to graph a line. Let's look at something very similar in this next problem here. Graph the line through 3, 1 with a slope of -4 and then find the equation. So this time they actually tell us to find the equation. We'll come back to that in a sec though. How is this problem different from the last one? Well, if we take a look at the last one, they gave us a slope and a y-intercept. Here, they give us a slope, but they don't quite give us a y-intercept. They just give us a point instead. Probably not going to be our y-intercept, right? We know that because neither one of these is zeros. It's not going to be our x, excuse me, our x-intercept either. It's going to be neither one of our intercepts, but it's still a good starting point. So let's use our starting point of 3, 1, and then we will use our slope as walking directions from there. But let's start with 3, 1. So we go out 3 and up 1. We know that it starts there. You know what? I'm going to put that in blue. So there's our starting point, 3, 1. Now from there we have a slope m of -4. The slope is a little harder to read than the last one, right? It's a little harder to read because it doesn't have a nice equal rise over run coordinated to it, as it is, right? It's just a whole number. So does that mean that we rise like down 4 and go over 4? Do we go back 4 and then up anything we want? Like, what does that mean? In order to use this, let's convert it into a fraction. So -4, any whole number over 1 is the same thing as just that whole number. So we can convert this back into a fraction by calling it -4 over 1. Then it becomes fairly obvious about what's the rise and the run. We'll call the -4 the rise and the 1 the run, right? And we use rise loosely because we know that -4 means we go down 4, but it's still -4 would be the rise and 1 would be the run. So let's go ahead and do that from our starting point, right? Not from 0, 0. We will go down 4, down 1, 2, 3, 4, and over 1 to get this second point right here. Awesome. And then we can connect the dots. Maybe we can connect the dots. Why aren't you letting me connect the dots? There we go. Connect the dots. All right, and then of course we would extend that all the way up here and all the way to the bottom of the graph. And it's not the best line in the world, but we have our line of the equation. Sweet. All right, so we got the first part. We graphed the line, right? Now they need us to find the equation. Well, we can always start with y equals mx plus b, right? And then we just plug in what we know. We plug in that m and b. Well, we know m is equal to -4, right? We just use that to graph a whole bunch of times. And so we can plug that in. Now here comes the tricky part. Unfortunately, unlike the last problem, they didn't just give us the y-intercept, right? We already talked about the fact that that point they gave us is definitely not the y-intercept because it's not 0, something. So we can't exactly just plug in the y value there. So this line is not going to be y equals -4x plus 1, right? And that's kind of a bummer. But there's really only one extra step we need to do. What they did give us was a point, right? They gave us some point that we know is a correct solution. They gave us an x and they gave us a y, right? They gave us x, y. So now we can use this x, y inside what we already know. So I know that somewhere on this line, y is going to be equal to 1, the slope's going to be -4, and x is going to be equal to 3. Just like they said in the point, right? That's the point we see right here that goes through. So whatever this b is, this plus b, this point has to be a solution, like we talked about in the first section, to this equation, because I know that I can use it to solve for b. So I'm going to plug in my x and y as I did, and then I can solve for b. Now since b is the only thing I don't know, I can actually solve for it. So 1 is equal to negative 12 plus b if I simplify this area a little bit, and therefore b is equal to 13. 13 is equal to b if I add 12 to both sides, right? So add 12 to both sides, you get b is equal to 13. So our final equation is y is equal to negative 4x plus 13. And we have found our equation. Oops. Awesome. All right. Now that's a very important step right there. So we're going to use this idea quite a few times where they give us a point and a slope. We're going to use it to graph a line. And then in order to find it, make sure you always solve for that b. That's a really important part. So if you have any questions right now about what we just did in this problem, make sure you pause the video and get them answered so that you can, so that the rest of the video will come just as easily as that problem did. Excuse me. Okay. The other concept we're going to talk about today, the rest of the day here, is parallel and perpendicular lines. So parallel and perpendicular, let's remind ourselves what that means. Parallel lines. Parallel lines look like this. And I'm sure if I were to ask you guys what is parallel line, or what are two parallel lines, what makes them parallel, a lot of you guys will tell me is that they never intersect, and you're absolutely right. Parallel lines never cross. They never intersect, no matter what part of the graph you're looking at. But there's a reason for that, and the reason for that is more of a formal definition. If you look up here, parallel lines have the same slopes but different y-intercepts. That's really the more formal definition of parallel lines. Again, you're not wrong if you were to say there are lines that don't intersect, and that's great, but we're going to use this idea a lot more than just the non-intersecting lines. So they have the same slope, but their y-intercepts are different. If they had both the same, they would actually just be the same line, right? If they both crossed at the same point and had the same steepness, they would be the same line. So, but parallel lines have, pardon me, different slope, or sorry, same slopes but different y-intercepts. And we can check that here. Here, if we look at the red line, which I believe on your notes, because of our photocopier, is probably black, they're both black, but the top line there has a slope that goes up 2 and over 2. So 2 over 2, that's going to be a slope of 1, right? And then if we look at the bottom blue line, we look, it goes also up 2 and over 2, so it looks like it is also a slope of 1. They have the exact same slope, right? However, if we look at their y-intercepts, the red line has a y-intercept of 4, while the blue line has a y-intercept of 2, right? These two dots right here. Therefore, I'm sorry, a y-intercept of 0, 4 and a y-intercept of 0, 2. So same slopes, different y-intercepts, therefore they are parallel. All right, let's leave ourselves a nice note here that parallel lines have the same slope. Notice how many times I've said this. It's probably going to come in handy later on, so make sure you've got that written down. Same slope. They are quite different from perpendicular lines. Perpendicular lines are the other kind of lines, special kind of lines we see too on a graph. Perpendicular lines, probably a lot of you remember, if I were to ask, you guys would tell me they are lines that cross, which you're absolutely right. But not only that, they cross at a 90-degree angle. We can see here on these ones, that is definitely 90 degrees, right? 90 degrees, so very special angle that they cross at. But again, that's sort of like a visual representation, and it's not really the definition we're going for. There's a reason they cross at 90-degree angles. The reason they cross is because they have opposite reciprocal slopes. Opposite reciprocal slopes. So they do not have the same slopes. They definitely don't have the same y-intercept, right? Because they're not even relatively similar. Like if you look at these two here, those are definitely not the same y-intercepts. But they have opposite reciprocal slopes. Now let's break that down piece by piece. What exactly does that mean? What does opposite reciprocal mean? Well, opposite, it refers to the sign of a number. So the sign would be the positive or the negative, right? So if it's positive, the opposite sign would be negative. If it's negative, the opposite side would be positive. So I just realized this wording here is garbage. It's for my old sign, my old graph there, so you can go ahead and cross this out because this has nothing to do with what we're talking about. The opposite sign would be, like, say you had 2, then the opposite would be -2. Or say you had -5, the opposite would be 5, right? So the opposite would be whatever sign. The reciprocal part is the fraction. So opposite, you switch the sign. Reciprocal, you flip the fraction. So for example, if you had 2, it would become 1/2. If you had 1/3, it would become 3. Or if you had something like 2/3, it would become 3/2, right? So you'd flip it just upside down. Perpendicular lines actually have both when it comes to their slope. So let's take a look at these two slopes right here. So let's kind of erase this little perpendicular mark so that we can look at these a little more. Let's take a look at the red one. We've got a slope of, from here to here, run of 3, rise of 2, right? So this is a slope of rise over run, 3/2, right? So 3/2. Now as for the blue one, you can look down here. It goes down 3 and out 2. So -3 and out 2. So this is a slope of -3/2. Notice these two, positive, negative, so they're opposite, right? And then the fractions are flipped, 2/3, 3/2. So these are perpendicular because their slopes are opposite reciprocals. Cool. Pause the video right now if you have any questions on that, because that's also a very important note. Okay, moving right along. Let's see if we can take these ideas and double check if lines are actually parallel or perpendicular. So example 4.1. Determine if these two lines are parallel. Now this may look a little strange, but it's basically how we're just going to define the two lines. So we've got line 1 going through these 2 points, -2, 1, and 4, 5. We've got line 2 going through 3, 0, and 0, -2. So it sounds like in the second line they gave us the y-intercepts and the x-intercept, which is very nice of them. But how can we use these points to determine if they're parallel? Very interesting. What do we know about parallel lines? Well, we know that they never cross, right? And we know that they have the same slope. So it looks like we're going to have to check to see if these two lines, line 1, line 2, have the same slope. Same slope. That's the question, right? Do they have the same slope? Well, they don't tell me the slopes. They tell me points. But if you remember back from the last section, how can I use 2 points to find a slope? What can I do? Alrighty, I hope you guys said the slope formula, right? I hope you guys paused the video and talked about that. But yes, you're right, the slope formula, that y2 minus y1 over x2 minus x1. Remember I said commit that to memory as fast as possible, so make sure you do that. Let's go ahead and do that. So I've got this, we'll do it for both. Let's do the line 1 in blue, and we'll do line 2 in pink. Alright, so line 1 in blue. Second y, 5 minus the first y1 over the second x4 minus the first y, -2. Oops, that's a 3, not a 2. Just kidding. So minus -2. We can reduce that down a little bit. We get 4 over 6, or 2/3. Awesome. Let's check the second one out now. So we'll do that one with the other 2 points. We have -2. Oops. So it's still y2 minus y1. So y2 was -2 minus y1 was 0 over x1 is 0 minus 3, which is negative, or minus 3, which is x1. Simplify, you get -2 over -3. Negative over negative becomes a positive, you get 2/3. So let's take a look at both of these. What can we say about these two lines? This one has a slope of 2/3, this one has a slope of 2/3. Ah, they are the same. And so we can say check, they are the same. Therefore, they are parallel. Now in order to save some time, I usually just write 2 slashes for parallel. You're welcome to do that as well. Or you can actually write the word out, parallel, but the conclusion is the same. These two lines are actually parallel to each other because they have the same slope. Alright. Go ahead and try this one out because it is virtually the same problem and I want you guys to practice with this. So go ahead and try this one out and then we'll reconvene in a couple minutes. Okay, so hopefully you've had some time to try this and you deduced something. Let's see what happens when we take the slope of both of these. So we have 2 points, this set of points, and this set of points. And so we're going to find the slope of each. So for the first one, we'll do it in pink. 8 minus 6 over 4 minus 3 gives us 2 over 1, or 2, right? So the first slope is 2. And we'll do it for the second one. These 2 points right here. 2 minus 10 over 2 minus 6 is equal to negative 8 over negative 4, which is equal to 2. Yes. All right. Hopefully my math's all correct there. Let me double check real fast. 2 minus 10, 2 minus 6, negative 8, negative 4. Yep. And it looks like they are, in fact, the same. So you should have gotten that, yes, they are parallel. That's. All right. Sometimes, however, they don't give us 2 points, right? In this one, they gave us 2 points. This one gave us 2 points. But we've seen many times that they don't give us 2 points, right? We've seen a whole bunch of times there are 2 points, and we're given the slope. How can we determine if 2 lines are parallel given 2 equations? What else can we do? Well, we could plug in until we found 2 points that work, and then we could go that way. Or instead, we could just find the slopes using the equations. So let's take a look at these. Let's take a look at these individually. I've got this first one, I've got this second one, right? I've got, a red equation, and I've got an orange equation. If we take a look at the red equation, 3x equals y. Well, it'd be very, very simple to get this into y equals mx plus b, right? I just have to switch it around. Y equals 3x. And since there's nothing to divide, y is already by itself. I can do plus 0 for b if I was concerned with that as well. So what is the slope here? Now that I've got it into slope-intercept form, I can easily pull out that m. M is equal to 3, right? Because that's what I'm going for here. I need to know if the slopes are the same to determine if they are parallel. So now I've got this first slope. The slope is m. The slope is 3. Taking a look at the other equation, my other equation is 2x minus 6y equals 5. That one's a little more complicated because y is not by itself already, which is a bummer. But I just need to get it into y equals mx plus b. So I can solve my minus 2x minus 2x. I get negative 6y equals negative 2x plus 5. It's again not quite solved all the way. So how am I going to get this y by itself? Divide it by negative 6. Remember, you got to divide everything by negative 6. Absolutely everything. So over here, I can just kind of scooch up. I get y is equal to, well, negative 2 divided by negative 6 is going to be a positive 3x. And then over here, a 5 divided by negative 6 is going to be a minus 5 over 6. And now it's in y equals mx plus b, which is great because I can figure out that right here, this 3 is our m, and the slope is equal to 3. All right. Again, hopefully that solving part is pretty fluent for you. If not, please make sure you get that. Make sure you buff up on that, okay? Alrighty, pause if you have any questions on how either one of those slopes were found. And now let's take a look at these 2 slopes. So in the red slope, the slope was 3. The orange slope, or the orange equation, the slope was 3. And so we can deduce that, yes, they are in fact parallel because they have the same slope, which is awesome. Alrighty, let's continue on. I believe there is another one here. Oh, never mind, just kidding. If you have any questions about parallels, whether finding them with two points or with equations, then make sure you get your questions answered, because now we're going to go on to perpendicular. Perpendicular is virtually identical, except that what is the difference between parallel and perpendicular? We know that parallel, they have the same slope. What does perpendicular have? And again, I'm going to use a little symbol, just a little upside down T, right? And I'm going to draw a better one real fast. So a little perpendicular sign. It's not quite the same slope, right? Instead, it's that weird one, right? It's opposite reciprocal slope. Opposite reciprocal slopes. Make sure you make a note of that, okay? Because that's where people often get confused. So now we're going to do the same thing, and we're going to have to see if they have opposite reciprocal slopes. So let's determine if 2 lines are perpendicular. Line 1 through 2, 9. And 14, 6, line 2 through negative 2, 8, and 6, 8. So let's take a look at that. All right, luckily, the process is the same thing, right? We still need to compare slopes, so we will still use the slope formula. We're not going to check that they're the same now, though. We're going to check that they are indeed opposite reciprocal. Excuse me. All right, so line 1. Let's do line 1 in pink, because I'm a girl and I like pink. All right, cool. So let's do the slope formula, right? We got the second point minus the first point. Hopefully by now the slope formula is a little easier, right? So we've got the second y, 6, minus the first y, 9, over the second x, 14, minus the first x, 2. I end up with minus 3 over 7. And since that doesn't reduce any further down, that looks like my, I'm so sorry, it's not minus 7. Silly Miss K, that's division. This would be over 12. And that does reduce down, right? I can divide those both by 3. I get negative 1 over 4. Negative 1 over 4, fabulous. Sorry, we're just going to clean up this a little bit. Alrighty. And that's our slope formula to find this first slope. Let's do the same thing with our second slope now. So we have our second line now. We have 2 more points. I can use blue over here for us gentlemen. For you gentlemen, I should say, because I'm not a gentleman, but that's cool. We have these 2 points here. The second one minus the first, with the second y minus the first y, over the second x minus the first x. Alright, and we end up getting 0 over 8, which is a slope of 0. Alright, what do we think? Do we think these are opposite reciprocal? Are they even opposite? No, they're not. So these are definitely not perpendicular. Not perpendicular. What slope would be perpendicular to the pink one? Let's talk about that. What slope would be perpendicular to negative 1/4? The slope that would be perpendicular, we'll put it in red so we don't get confused. The opposite of that would have to be positive, right? And what would be the reciprocal of 1/4? That would be 4. Very nice. That would be the opposite to that one. What would be the opposite reciprocal to 0? What would be opposite reciprocal to 0? Interesting, right? Well, first off, 0 is neither positive nor negative, so it doesn't have an opposite part. That's interesting. So it would still just be, well, yeah, it wouldn't be positive or negative. So that's already, that's already hard. What about the reciprocal part? If I have 0 over 8, what's the opposite of that? 8 over 0. Let's write that a little better. So 8 over 0. And what do we call that when we divide by 0? Does not exist, right? So the opposite slope to a 0 slope would be does not exist. So neither one of these were the other one, right? This one needed a 4 in order to be perpendicular. This one needed to be does not exist in order to be perpendicular. And therefore, it was definitely not perpendicular. Alrighty. If you have any questions about that, please pause the video. Okay, but sometimes, just like in the last one, we were given equations, pardon me, instead of points. So let's do the same thing we did for the parallel slopes when given equations, right? Let's deduce if these ones have slopes that are opposite and reciprocal. So let's take this first equation. We'll do it in red over here. 2y equals 3x minus 6. 2y equals 3x minus 6, right? As it is now, we can't take a look at the slope, because why? Why can't we look at the slope when it's 2y equals 3x over 6? It seems to be in slope-intercept form, but that 2 is in the way. You're right, that 2 is a problem. So we divide by 2 to everything, and we get that the actual slope-intercept form would be 3/2 x, and then 6 divided by 2 would be minus 3. And what does that say about our slope here? That says that our m is equal to 3/2. Nice. So as soon as we have that slope-intercept form, we can just pull it right out, right? Okay, so m is equal to 3/2. Right now, that's fabulous. We know that it's 3/2. We can't make any assertions on whether it's perpendicular or parallel yet, because we don't know the slope of the other one. So let's go take a look at the slope of the other one at the same as well. So we've got 2x plus, pardon me, that is a typo. This second one should say y. Not x. So 2x plus 3y equals negative 6. I believe it was fixed in yours. It was not fixed in mine. If it wasn't, though, please make sure you make that correction. Just a little typo there. 2x plus 3y equals 6. Again, this one is not in y equals mx plus b. It's in what kind of form? What form is it in currently? Standard. Very nice. It is in standard form. So right now we have to switch it. We'll start with as far away from the variable as we can. We'll subtract 2x from both sides. Variable in question. Alright, so now we have 3y is equal to negative 2x plus 6. And then we can divide by 3 to everything. Notice 1, 2, 3 terms, 1, 2, 3 divisions, right? Everything gets divided. Y equals negative 2/3 x plus 6 divided by 3 is 2. Alright, so what does that mean about this slope? What can I say this slope is equal to? Now it's in y equals mx plus b. Y is all by itself, and therefore it's right here where m sits. So m is equal to negative 2/3. What can we say? Can we conclude that these are perpendicular or not? What do you think? We've got 3/2 and negative 2/3. Well, it's definitely opposite, right? One's positive, one's negative. And then if we look at the fraction, it's 3/2 and 2/3. These are indeed perpendicular. Check. Sweet. Now, if that was negative 2/3 and this was positive 2/3, that would not be perpendicular. If this was 3/2 and that was 2/3, that would not be perpendicular, right? It has to have both the sign change and the reciprocal change. Alrighty, you guys take a second, pause the video, try out this next little system of equations, these two equations, and I want you to tell me if those two are in fact perpendicular. What do you think? Are they perpendicular? Okay, I hope you had paused the video and actually computed this out yourself. I hope you guys talked about it as a class. But let's do it together right now. So I'm going to convert these real fast. 4x minus y equals 8. Subtract that. Get negative 4x plus 8. And y equals positive 4x minus 8 when you divide. So my slope for this first line is going to be a 4. I'll do the same thing for the other one. I'll use a different color. 4x plus 3y is equal to 12. Move the x over, so 3y is equal to negative 4x plus 12. Divide by 3, you get y is equal to negative 4/3 x plus 3 divided by 12 is 4. And therefore my slope is going to be, oops, that's not an m, silly Miss K. 4. M is equal to negative 4/3. Ooh, these are very, very similar. They've got 4s, they've got sign switches, but they are not perpendicular. Because one is a 4 and one is a 4/3, right? It's not even close. Alright. If you have any questions at all about parallel and perpendicular, please make sure you review them now. They are going to be quite a big subject on your tests coming up, and your quiz coming up, so please make sure you know what you're doing. Remember, parallel lines have the same slopes. Perpendicular lines have opposite reciprocal slopes, right? Opposite reciprocal slopes. Alright, section 3.3b, these are the notes. So we left off last time by talking about horizontal and vertical lines, right? And what those equations look like. Now we're going to jump into parallel and perpendicular, but let's remind ourselves a little bit of what we were talking about beforehand. When we were given the slope of a line with 2 points, or we were given the slope of a line with if we were given a slope and a point, right, we could go ahead and find the equation by plugging into either point-slope form or into slope-intercept form. And then if they asked, we could convert it back to standard form, but that was sort of an extra thing. So we ended up with an equation that looked like this. Today, we're going to wrap in two concepts. We're going to talk about parallel and perpendicular, and we're actually going to find a parallel and perpendicular line given another line. So basically the steps today are written down right here. Got a nice, easy step-by-step sort of situation going on here. But I find it's always easier to just do an example problem, and then if something doesn't make sense or if you forget a step, you can refer back to the steps to find parallel perpendiculars given an equation and a point. So let's just start with example 5.1. All right, example 5.1. Find the equation of a line passing through the point, negative 4, 5, that is parallel to 2x plus 3y equals 6. Well, let's remind ourselves of a few things before we really dive into this problem. So parallel lines. Parallel lines have what kind of slopes? What kind of, well, okay, I'm going to rewrite that. Sorry, guys, that's just not coherent at all. So parallel lines have what kind of slopes? What kind of slopes do they have? That's right, they have same slopes. They have the exact same slope. So if if line number 1 has a slope of 3, line number 2 has a slope of 3, right? So the first thing we're going to need to do is find that slope. We're going to need to find what's the slope of the first line, so we can go find the slope of the second line. So here we'll start looking over this equation. How can we take this equation and find the slope? Well, we can either plug in a couple points until we find those points and then use the slope formula, or it'd be much easier to just rearrange this into y equals mx plus b. So let's start with that. First, we're going to find the slope. We don't need to write this because it's been written down. So first, we're going to find that slope. Number 1. So I've got the equation 2x plus 3y equals 6. 2x plus 3y equals 6, right? That's what I have. I need to put that into a slope-intercept form or into a point-slope form so that I can see the slope, right? Standard form as it is does not show us the slope. So let's go ahead and rearrange. Seems like you guys like point-slope form, or slope-intercept form, pardon me, slope-intercept form a little more, so let's go ahead and do that. So I'll subtract 2x from both sides. The goal is to get my y by itself. So I have 3y equals negative 2x plus 6. Divide by 3. And I end up with the line y equals, I don't want to write it there because I'm running out of room. I'll go write it up here. Y equals negative 2/3 x, and then 6 divided by 3 would be 2. Remember, you have to divide 3 to everything. Just like when we're converting back, we have to multiply that 3 to everything, right? So make sure that when you divide, that b also gets divided into a 2. All right. So now that we've done that, this is all just still the first line. We have not found another equation yet. So we found the first line. We need the same slope. So what slope is here? What can we call slope number 1? Good, negative 2/3, right? That's the slope here. Our slope number 1 is negative 2/3. So this is all for the first line. We'll call it line 1. This is the first line. Slope 1 is negative 2/3 for line 1. Now for line 2, we can use a different color. What does that slope have to be? What does that slope have to be? It's not a trick question. Right, it's got to be exactly the same. It's got to be negative 2/3. So we know that this slope is negative 2/3. Fabulous. All right, we found the first thing we need, slope. Now the second part we need is to find the equation. So if you have any questions at all, make sure you pause on how to find the slope. We need a matching slope here. All right, so now we're going to change, or basically what we've been given now is a problem where they gave us a slope, m is equal to negative 2/3, right? And a point, let's see, what was the point they gave us? The point they gave us was negative 4, 5. And now it sounds exactly like the problems we were doing last time. Here's a slope, here's a point, go find the equation, right? So once you find that slope and you're given a point, you can find it either through point-slope form or through slope-intercept form. I'm going to do point-slope form. So y minus y1 is equal to m times x minus x1. All right, I'll plug in my slope and I'll plug in my point. So I've got y minus, let's see, my y here in the point was 5. You know what? I'm going to write a little smaller because we are running out of room. So y minus 5 is equal to, let's see, that slope is negative 2/3. X minus, and that point, the first half of my point was negative 4, minus a negative 4. Watch those double negatives, right? Alrighty. Now I will simplify a little bit. Simplify just a little bit. If it asked for it in point-slope form, this would have been a perfectly acceptable answer, right? I could just leave it right here. But since I'm used to saying it in y-intercept form, or maybe you did it in y-intercept form and you want to make sure your answer matches, let's just simplify a little bit. So I can distribute that negative 2/3 in. Y minus 5 equals negative 2/3 x. Let's see, that would be a positive 4 times 2/3. Times negative 2/3 would be negative 8/3. And then I add 5 to both sides. Y equals negative 2/3 x plus, let's see, that would be 15/3 plus or minus 8/3 would be 7/3. And there's our equation. Sorry, guys. All right. So this equation, this line 2 here, this line 2 is going to be parallel to this equation because notice it's got the same exact slope, and different y-intercepts. So that's how you would find the parallel line to this first one. And we know that since we use this point to find this equation, we know that this one would go through negative 4, 5. All right. This next problem right here, problem B, is extremely similar. In fact, I believe the only things that are different are the points in the equation. So I would like you to try it first. So go ahead and pause this video right now, and I want you guys to try it on your own. Okay, so try the same thing. You're going to take line 1, find that slope, find the same slope, and then find me a new equation. All right, go ahead and try that now. Alright, I hope you paused the video. We're going to do this, I'm going to do this very quickly. So if you hadn't done it already, remember the worst thing you can do is not try in class. You need to try it in class, otherwise what's the point, right? If you think you can do it now, that's great, but you may be wrong. You may be wrong and then you're going to go home and have 4 hours of homework because you have to do this like 50 times. So don't put yourself in that position. Alright, we'll start with line 1. Oh, sorry. So line 1 has the equation 3x minus y equals 8. Minus y equals 8. We can rearrange that to find the slope. I know I need the same slope, so we'll rearrange that. Negative y is equal to negative 3rd x plus 8. Subtract the x over. Divide everything by a negative so that y is positive. You get 3x minus 8. Alright, so my slope here is equal to 3. It's my slope 1. My slope 2 needs to be exactly the same. Let's use a pretty color. Let's use like purple. My slope needs to be exactly the same. So M2 is going to be 3 as well. Now, and then it goes through the point 7, 2. Now I can solve this like last time. I have a slope of 3 and a point 7, 2. I'll mix things up. I'm going to use the y-intercept form in case you did. If you did point slope form, you still should have gotten the same answer. But I'm going to use y equals mx plus b. So I'm going to plug in my 3, my 7, and my 2. So y is 2, m is 3, x is 7, and I get b. Or plus b. Remember, b is the part I'm solving for. It should not be the part I plugged in for. Alright, 2 is equal to 21 plus b. 2 looks like b, so minus 21 to both sides. You get negative 19 is equal to b. So y is equal to 3x minus 19. And we have our equation. Notice this has the exact same slope as the last one, right? But it has different y-intercepts, so they are indeed parallel. This is line 2. Alright. Hopefully that's what you got as well. Alright, the next one is find the equation of a line passing through point negative 4, 5 and perpendicular to 2x plus 3y equals 6. This sounds verbatim, this question, except for one word. What's the only thing that's different between these two? That's right, the word perpendicular. Let's remind ourselves what that means. Well, perpendicular lines, right, intersect at a 90-degree angle. But what does that mean about their slope? So we can go back up here. Perpendicular lines do not have the same slope. They have what? Opposite reciprocal slopes. If you didn't remember that, you need to make sure you remember that means opposite reciprocal, and it has to be both, right? So 2 would become negative 1/2. So positive 2, positive goes to negative, 2 becomes 1/2. We can leave that a little note right here. 2 becomes negative 1/2. That's opposite reciprocal. All right, let's go down and actually do that now. Other than that, it is literally the same problem. It is just exactly the same. So since, again, we're dealing with slopes, right, opposite reciprocal slopes, we should put that note down. Since we're still dealing with slopes, we need to find the slope of this first line. So let's go ahead and find that slope. Well, we already did, but let's do it again just for practice, right? So line 1 is 2x plus 3y is equal to 6, right? So we can subtract 2x from both sides and get 3y is equal to negative 2x plus 6. And then divide by 3, we get y is negative 2/3 x plus 2. And again, we can see that our slope is right sitting there next to x, so slope 1 is equal to negative 2/3. I'm going to write that a little better. Negative 2/3. Right? All right, so once y is by itself, we can find that first slope. So that's all for line 1. Now we have to be careful. At this point in the last problem, we deduced, okay, we needed the same slope, right? Parallel. I needed 3, I got 3. I had negative 2/3, so my next slope was also going to be negative 2/3. Here, that is not the case. Here, my next slope is going to be the opposite reciprocal from that, right? So the opposite, well, this first one's negative, so this one's going to be positive, right? And then I'm going to reciprocate it, or I'm going to flip the fraction over. Positive 3/2, pardon me. Positive 3/2. So it's not going to be negative 2/3, it's in fact going to be positive 3/2. It's going to be the opposite and reciprocal. But from there, once we've done that, it's the exact same problem. So we can take that new slope, m2 is equal to 3/2. And the point, let's see, what point did they give us? It was the same exact point, so negative 4/5. And now it's just the problem where we have a slope and a point, and we can go and find the equation that matches using either point-slope form or a slope-intercept form. Once again, I'm going to use point-slope form just for repetition's sake. So let's keep going. So y minus y1 is equal to m times x minus x1. Plug in what I know. I know that the y1 was 5. The m was positive 3/2. And the x1 is negative 4. All right, looking good. And then I can simplify a little bit just to make sure we match with anybody who might be doing it point-slope form, right? Or sorry, slope-intercept form. Want to make sure it's the same thing. So we can distribute that 2/3. Get y minus 5 is equal to 3/2 x. Let's see. That would be a positive 4 times that would be 12 divided by 2 would be plus 6. In case you didn't catch that, positive 4 times 3/2 would be 12/2 or 6. Right, so that's what I did right here. Alrighty, and then I just have to add 5 to both sides. I end up with the line y equals 3/2 x plus 11. And there is my line. Notice these two are not parallel. They do not have the same slopes, but they do have opposite reciprocal. Negative 2/3, 3/2. They do not have matching y-intercepts either. Never is that the case. Their y-intercepts should never match. But they have opposite reciprocal slopes. Alrighty. This next problem is virtually the same, right? It's got just a different point, different equation. So I'm going to let you guys handle it and take a look at it, get questions answered, try it out. Go ahead and pause the video and give yourself a shot. Alright, hopefully you pause the video. I'm going to do this pretty quickly because you should already have it done on your page. Remember, if you don't try, the only one you're hurting is yourself, right? So let's try this out. So I've got this line, it's line 1, do green, of 2x minus y equals 7. So line 1 is 2x, line, come on. Sorry, one sec. Okay, let's get rid of this. Line 1 is 2x minus y equals 7. Got to rearrange that to find my slope. So negative y is equal to negative 2x plus 7. Divide by a negative, or divide by negative 1, you get 2x minus 7. So m is equal to 2, m1. That first slope on the first line is equal to 2. Now for m2, I don't want the same slope, I want perpendicular, which is opposite reciprocal. So right now it's a positive slope, therefore my opposite reciprocal will be a negative slope. It's a 2, so it's going to be a reciprocal of 1/2. So change the sign, change the fraction, right? If it's a whole number, it's 2 over 1. You flip it over, it's 1 over 2. And then my point was 8, 5. So point of 8, 5. And I'm going to use that to find my equation. Just like last time, I'm going to switch it up. Instead of using point-slope form, I'm going to use slope-intercept form, because why not? They're about the same amount of work. So y is equal to mx plus b. And I'm going to plug in what I know. I know that y was 5. I know that m was negative 1/2. And I know that 8 was x. But I don't know b, right? Because neither one of those said 0, something, right? Or, sorry, 8, 5 is definitely not 0, something. So now I'll solve this out a little bit. I have 8 times negative 1/2. Well, that's 8 divided by negative 2, or negative 4. So 5 equals negative 4 plus b. Gotta make that look prettier. Negative 4 plus b, right? So what plus negative 4 would be 5? We'll add 4 to both sides, and you get that b is equal to 9. So my final equation is y equals negative 1/2 x plus 9. Should have gotten the exact same thing with point-slope form, no matter what. Alright, that is parallel and perpendicular lines. Alright, the last thing we're going to talk about is modeling real data, but let's just review this part real fast. So finding a parallel or perpendicular, you first need the slope, then you need to find out whether you need the same slope or an opposite reciprocal slope, and then you solve it given point-slope form or slope-intercept form, either one. Alrighty, cool. That's pretty much summarized in these forms down here. You've got this forms of linear equation. You can see we've got the y equals mx plus b, the slope-intercept form, tells you where it would be applicable. You've got your point-slope form, you've got your standard form, so and then where they would be most useful. But remember, you can convert between any one of these. And then down here, it's got also the slope, the horizontal line, and the vertical line. So this might be a good thing to keep in your notes for when you're studying for that quiz coming up, right? Hint, 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 or the unit test. This might be a good thing, or even just later on in life. It might be a good thing to keep like committed to brain, or at least have it sort of as a backup.